Bismillahirrahmanirrahim. Dear students of 9C, Assalamu alaikum. I am your teacher, Muhammad Ilyas. Dear students of LPS, this is our 10th interaction regarding chemistry for Cambridge. Our today's topic is from the energy from chemicals, the topic number 5 according to CI syllabus, and experiment number 10 according to your book Practical Chemistry, a course for O level volume 1. Dear students of LPS, our objectives are as follows. We will be able to understand practical procedure and solve the questions given in your practical journal by focusing the meaning of the enthalpy change in terms of exothermic and endothermic reactions. Secondly, we will focus on to demonstrate the production and absorption of heat during chemical reactions. So, dear students of LPS, these are our objectives for today's session. We are going to start with the revision of this topic, enthalpy. Dear students of LPS, enthalpy is the amount of energy in a system. The enthalpy change of a system is the amount of heat energy given out or taken in when the system reacts at constant pressure. Any change in the enthalpy of a system is represented by the symbol delta H. Enthalpy is the amount of energy in a system, and enthalpy change is denoted by the symbol delta H. And in a chemical reaction, both the reactants and the products will have a certain amount of energy, and that energy is represented by delta H, and the unit of enthalpy are in joule or kilojoule per mole. Dear students of LPS, this is the graphical representation of enthalpy change. You can see a reactant starts working, and before going to form the products, they need an activation energy. Dear students, the small amount of energy is called activation energy, and this is the minimum energy needed to start a chemical reaction. So activation energy is the amount of energy which is needed to start a chemical reaction, and that is the difference between the energy of the reactants and products. Dear students of LPS, the energy of the products may be less than that of the reactants. The energy is therefore given out during the reaction, and the energy of the products of a reaction may be more than that of the reactants. Energy is therefore taken in during the reaction, as you can see in these two graphical representations. Dear students of LPS, now we are focusing on the exothermic reactions, a reaction in which heat energy is given out to the surroundings. It's said to be an exothermic reaction. Heat energy is lost, therefore the system moves to a lower energy. The change in the enthalpy delta H is negative for exothermic reactions. The change of energy takes place in an exothermic reaction can be represented by an energy level diagram, as you can see. Dear students of LPS, although there is a net loss in energy during an exothermic reaction, energy must be supplied to the system in order to start the reaction off. This is the activation energy. Notice that the delta H is the difference between the energy level of the reactants and the energy level of the products, and does not include the activation energy. When the enthalpy change for a certain reaction is given, it is usually written to the right of the equation for the reaction. Dear students of LPS, now we are focusing on the endothermic reactions. A reaction in which heat energy is taken in from the surroundings is said to be endothermic. Heat energy is gained, therefore the system moves to a higher energy level. The change in enthalpy delta H is positive for the endothermic reactions. Although there is a net gain in energy in an endothermic reaction, activation energy is still required to start the reaction. The students of LPS, don't be confused by the sign of delta H in the reactions. Remember that the delta H is not the energy lost or gained in the reaction, but the decrease or increase in internal energy resulting from a reaction. After having this understanding, we are going to summarize the exothermic and endothermic reactions. You can see here is a comparison between these two kinds of reactions. In exothermic reactions, energy is given out to the surroundings, while in endothermic reactions, energy is taken in from the surroundings. In exothermic reactions, delta H is negative, while in endothermic reactions, delta H is positive. In exothermic reactions, products have less energy than the reactants, while in endothermic reactions, products have more energy than the reactants. Dear students of LPS, to understand this enthalpy change, we have to understand the making and breaking of the bonds. In order to understand why internal energy of a system changes and why activation energy is needed, it is necessary to think about what is happening during a chemical reaction. The following equations represent the combustion of methane. Methane is going to react with oxygen and form carbon dioxide and water molecule, as you can see from this pictorial representation. In each molecule of methane, a carbon atom is bonded to 4 hydrogen atoms. That is, there are 4 carbon hydrogen bonds. Similarly, in each oxygen molecule, there is an oxygen double bond with the oxygen another atom, and these bonds must be broken before the reactions can start, which is why activation energy is needed. Once the reaction is underway, 2 carbon oxygen bonds form to make each molecule of carbon dioxide, and 2 hydrogen oxygen bonds form to make each molecule of water. Energy is given out when bonds are formed. Breaking bonds requires energy, while making bonds releases energy. In an exothermic reaction, the energy needed to break the bonds of the reactants is less than the energy released when the bonds of the products are formed. This extra energy is given out as heat. In an endothermic reaction, the energy needed to break the bonds of the reactants is greater than the energy released when the bonds of the products are formed, and this extra energy is taken in as heat. So this is how the bonds make and break. Dear students, now we are going to focus on our experiment, and this is experiment number 10 according to your book. And the experiment is to demonstrate the production and absorption of heat during chemical reactions. And for this purpose, we need apparatus, glass test tubes, measuring cylinders, test tubes rack, thermometers. And the materials which are required: the concentrated sulfuric acid, zinc powder, ammonium nitrate crystals, 1 mole per cubic decimeter copper sulfate solution, calcium chloride, dilute hydrochloric acid, iron fillings, potassium hydrogen carbonate, sodium hydroxide pellets. This is the diagram of the apparatus. You can see the test tubes, the test tube rack, the measuring cylinder and a thermometer. Dear students of LPS, now we are moving towards the procedure. Take the temperature of 5 cubic centimeter of tap water and then add 2 drops of concentrated sulfuric acid to the water and stir it well. Take the temperature of the mixture. Number 2, repeat the step 1 but use 1 gram of ammonium nitrate crystals instead of the concentrated sulfuric acid. Step 3, repeat the step 1 but use 2 gram of calcium chloride water 6 water instead of the concentrated sulfuric acid. Fourth point, repeat the step 1 but use about 5 pellets of sodium hydroxide instead of the concentrated sulfuric acid. Point 5, take the temperature of 5 cubic centimeter of hydrochloric acid dilute, add 1 gram of potassium hydrogen carbonate to the acid and stir. Note the temperature of the mixture. 6. Take the temperature of 5 cubic centimeter of mole per cubic decimeter copper sulfate solution and add about 0.7 gram of zinc powder and stir well. Record the highest temperature. 7th, take the temperature of 5 cubic centimeter of mole per cubic decimeter copper sulfate solution and about 0.7 gram of iron fillings you have to add in it and stir well. Record the highest temperature. So this is the procedure. Now we are moving towards the first step. We have to take the 5 cubic centimeter of tap water, take its temperature and then add 2 drops of concentrated sulfuric acid and then stir it well. Take the temperature of the mixture. When you mix concentrated sulfuric acid and water, you pour the acid into a larger volume of water. Sulfuric acid reacts very vigorously with water in a highly exothermic reaction. If you add water to the concentrated sulfuric acid, it can boil and spit and you may get a nasty acid burn. So when you are going to mix, you have to always mix the acid in water, not water in acid. The step 2, we have to take the 5 cubic centimeter of tap water and then add 1 gram of ammonium nitrate. You can see from this diagram, and before adding you have to note the temperature of the water and then you have to add ammonium nitrate. And you can see from this diagram heat energy taken in as the mixture returned back to the room temperature. That will happen next, but first the solution will get cools to the 5 degrees centigrade. Now we are moving towards the step 3. We have to take 5 cubic centimeter of tap water, take the temperature of it and then add 2 gram of calcium chloride 6 water instead of the sulfuric acid, and you can see a significant release of heat reaction of calcium chloride and water. Calcium chloride combined with the water and form the HCl and calcium hydroxide, and this is also exothermic reaction. And then we have to take the 5 cubic centimeter of tap water, note it down its temperature and then add about 5 pellets of sodium hydroxide and then stir it well. You can see the temperature of the solution rose. We say this change is exothermic and we have to note down the temperature. Dear students, now we have to take the temperature of 5 cubic centimeter of dilute hydrochloric acid and then add 1 gram of potassium hydrogen carbonate to the acid and stir. And you can see in this reaction three products are formed: potassium chloride, water, and carbon dioxide gas is released. And this is also a exothermic reaction. And then you have to note down the temperature of this solution after the reaction is going to be completed. Dear students, take the temperature of 5 cubic centimeter of 1 mole per cubic decimeter concentration of the copper sulfate solution and then add about 0.7 gram of zinc powder and stir well. Record the highest temperature. You can see zinc is going to displace the copper, and in this process the heat energy is lost because this is an exothermic reaction. You can see what is going to happen. This is the copper sulfate solution, which is of blue color. When you add the zinc, the blue color will disappear and the solution become colorless. Dear students, we have to repeat the step 6, but use the 0.7 gram of iron fillings instead of the zinc powder, and you can see the blue copper sulfate solution is going to change to the green iron sulfate solution, and the copper is going to attach on this nail, iron nail, and this is also an exothermic reaction. So after performing these reactions, we have to note down the temperature, initial, final, and then the difference of all these 7 steps according to this table. First of all, we have to note down the initial temperature and then the final temperature, and then we have to find out the difference of the temperature. This table is given in your book. Dear students, I have selected homework for you. You have to solve all the questions given in your practical book of the experiment number 10, and this is these questions are present on the page number 34. You have to solve the questions and then send to your respective groups for evaluation. Dear students, here are a few words for you as a spelling test. You have to memorize the spelling of these words and then write on your notebooks and then send to your respective groups. The words are as follows: the demonstrate, apparatus, cylinders, absorptions, thermometer, concentrated, hydrogen carbonate, pellets, exothermic, and endothermic. You have to memorize these words and then send to your respective groups for evaluation. And here is a test for you. You have to discuss the difference between exothermic and endothermic reactions. Illustrate your answers with the graph as we have discussed earlier. You have to memorize this and then write in the answer of this question into your test notebooks. Question number 2, which I have selected for you, you have to discuss the breaking and making of bonds with reference to enthalpy. Dear students of LPS, you have to write down the answers of these questions in your test notebooks and then send to your respective groups for evaluation. Dear students of LPS, thank you very much for staying with me, and one more request to you: please be at home, stay at home to stay safe. Allah Hafiz.